So if I have two commodities, right, that I'm consuming, Q1 and Q2, then there's a level of satisfaction that I will derive from consuming those two commodities, okay? The graphical representation of that level of satisfaction is what I call utility, my indifference curve, okay? So that's the graphical representation of my utility that I've consumed. So if I have Q1, I have Q2, and I consume Q1, consume Q2, the combination of those two commodities, its representation on a graph is called my indifference curve. So let's plot a simple indifference curve on our board. So I have this and I have this. All right. So I'm making an assumption that there are two goods I'm consuming. This is Q2. This is Q1. These are the two goods I'm consuming. Okay. So this is my indifference curve. I1. Okay, I'm sorry that my graph might not be so perfect. I'm so sorry. You know, if it to be a board, that would have been a perfect drawing. Now, this is my indifference curve. So what is the indifference curve? The indifference curve is a curve that shows the combination of two commodities that can be consumed, all right, in which the same level of satisfaction is maintained. So, for example, let me call this point A. Let me call this point B. And let me call this point C. At point A, I'll trace it to this place and I'll trace it down. Look at it. So at point A, let me say I'm consuming Q2 prime level of commodity. And at that point A, I'm consuming Q1 prime. Okay. Q1 prime. Let me use the prime here. Sorry, let the prime be here. Let the prime be here. So, all right. So at point A, I'm consuming Q2 prime level of commodity, and I'm consuming Q1 prime level of commodity. At point B, look at what happened. I'm now consuming Q2 prime level of commodity, while I'm consuming Q1. Okay, I'm just using it to differentiate one point to the other, level of commodity. At point C, what happens? I'm consuming Q2 prime level of commodity, while I'm consuming Q1 prime level of commodity. What happens, for example, if I move from point A to point B, you will discover that Q2 prime, which is the quantity of goods 2 I'm consuming, is higher than Q2 prime prime, Abi, because this particular level is higher than this level. So at point A, the quantity of Q2 I'm consuming is high. But at point B, the quantity of Q2 I'm consuming is low. What about Q1? At point A, the quantity of Q1, which is Q1 prime, is lower than the quantity of Q1 prime prime at point B. So this is point A, this is point B. You can see in point A, Q2 prime is higher than what? Q2 prime prime. Okay? And at that same point A, Q1 prime is lesser than what? Q1 prime prime. What does that mean? It means a movement from point A to point B. What happened? Q2 commodities, some level of Q2 commodities was given up. Okay, I gave up some level of Q2 commodities so that I can gain some level of Q1 what? Commodity. Yet, my level of satisfaction remains the same, did not change. So that is my indifference what? Curve. It is that curve that shows different combination of goods that I can consume, such that my level of satisfaction does not change. So whether I am at point A, I'm at point B, I'm at point C, my level of satisfaction remains the same. So at point A and B, my utility at point A is equals to my utility at point what? B, and is equals to my what? Utility at point what? Point C. So my level of satisfaction does not what? Change. Although my quantity of commodities consumed changed. Quantity A was at Q at point A. Quantity 2 was higher than quantity 2 at point B. But quantity 1 is lesser than quantity 1 at point B. So, though my combinations are different, but my level of satisfaction remains unchanged. That's my indifference what? Curve. Now, let's look at the properties of what? Our indifference curve. The first property of my indifference curve is that my indifference curve is established on the first quadrant of my my plane shape. My indifference curve is established on the first quadrant of my plane shape. What do I mean? You remember in maths, these are our quadrants where you have y-axis, okay? This is x-axis. If you remember in your maths, this side is the positive, this side is the negative. This side is the positive, this side is the negative. This is my point of origin, 0. This is my first quadrant, this is my second quadrant, this is my third quadrant, this is my fourth quadrant. The first property of my indifference curve is that my indifference curve is established on the first quadrant. That means my indifference curve is established on this first part. And at this first part, what happens? Y is positive, X is also what? Positive, meaning the two goods I'm consuming are positive. Remember, my assumption of my utility function previously, I have said I cannot have negative commodities consumed. So if I cannot have negative commodities consumed, that means Y or X can never be negative. Q1, Q2 can never be what? Negative. And once Q1, Q2 is not negative, invariably, what happens? My graph must be drawn on the first quadrant. That is why in this indifference curve, you can see my point of origin 0. Then this up part is where I drew my what? Indifference curve. I cannot draw my indifference curve on this region. I cannot draw my indifference curve on this region. And I cannot draw my indifference curve on this region. I can only draw my indifference curve in the first quadrant. That's the first property of my indifference curve. What is the next property of my indifference curve? The next property of my indifference curve says that the farther an indifference curve is from the origin, the higher the level of what? Satisfaction. This is point 0. This is my origin. My 0 is my origin. So I have two goods, Q2, and then these other goods, Q1. Now, if I have different indifference curve, this is one indifference curve, this is another what? Indifference curve. This is another what? Indifference curve. This is indifference curve A, for example. This is indifference curve B, for example. And this is indifference curve C, for example. The property says, remember that any point on this indifference curve for A, my satisfaction remains the same. But the satisfaction of the point indifference curve B is different from that of A. And the assumption, the property says that the farther the indifference curve is from the origin, the higher the level of satisfaction. That means the satisfaction derived for indifference curve B is higher than that of A, because indifference curve B is farther from the origin, compared to indifference curve A. And if you look at indifference curve C, is farther from the origin, compared to what? B, compared to what? A. So what does that tell you? That tells you that the satisfaction of indifference curve C must be higher than the satisfaction of indifference curve B, and must be higher than the satisfaction of indifference curve A. So I can firmly conclude that the farther the indifference curve is from the origin, the higher the level of what? Satisfaction. The next assumption says that two indifference curves can never meet. Two indifference curves can never meet. Of course, in your elementary, all of this combination of these indifference curves are called your what? Indifference map. You know that. So the next property says that two indifference curves can never meet. So what does that mean? It means I cannot have an indifference curve like this. It's wrong. I cannot say this is indifference curve A. This is indifference curve B. Can anybody tell me why I cannot say that? Anybody?
Because they don't have the same level of satisfaction, sir.
Exactly.
Exactly. So, and that means if I say point A, for example, here, and I say point B, for example, all right, and I have point C, you might see this in an exam, and I draw this graph, and I'll say, given this indifference curve, comment on the nature of this indifference curve. You should be able to explain to me using the properties of indifference curve. How? You see that at point A is on indifference curve A. Point B is on indifference curve B. Honestly, using the farther the indifference curve is from the origin, the higher the level of satisfaction, I can say that the satisfaction at point A is higher than the satisfaction at point B, because indifference curve A is lying outside, are farther than indifference curve B. But what about point C? In point C is on the indifference curve of A and also an indifference curve of B. Since point C is an indifference curve of A and indifference curve of B, it therefore means that points A and C are the same because they are lying on the same indifference curve A. It therefore also means that point C and point B are the same because they are lying on indifference curve what? B. That means because of this point C, A is now equals to what? B. But if you compare A and B initially, indifference curve A must be higher than indifference curve B. You see, the assumption of the father the indifference curve from the origin has been violated because of the intersection at point C. You can now conclude that two indifference curves cannot meet, simple as ABC. So when you see the graph, you see the comment on the nature of the indifference curve, 4 marks. You don't need to blow too much grammar. You all need to do what? Tell me, using the assumption of what? The property that the further the indifference curve is from the origin, the high level of satisfaction, so A is greater than B. But now come that since C is lying on point on indifference curve A and B, A must be equals to C. The level of satisfaction at A must be equals to C, and level of satisfaction at B must be equals to C. Thus, the assumption of that further the difference curve is from the origin has been violated. Okay, I believe I have been able to explain that. So I've told you 3 properties. The 4th property is that the indifference curve is convex from the origin. Tolulope, David.
Yes, sir. Please, I'm trying not to. So I don't want you to go too far before I ask question on the second
Property.
The second property. Yes, sir.
The father.
Yeah, I think that the further the
indifference curve is, yes.
satisfaction.
Yes.
Yes, sir. I'm just struggling to relate it to, I mean, a real scenario. I don't know if you can help us with that.
Okay.
So,
okay.
Yes, sir.
You know that whenever you consume your commodity, you will record it.
Yes, sir.
Okay. Now, if you remember your production possibility curve, you'll be able to answer this question you've asked. Look at this now. If you notice at this point, this level is consumed. This level is consumed. But if you notice at this point, for example, that same old level of Q2 is consumed, but a higher level of Q1 is consumed. That means in this point, let's say 2 gari, 2 cup of gari is consumed. While at this point, 5 bottle of Coke is consumed, assuming I have gari and Coke. But you see at this point now, the same 2 gari is consumed, but a higher level of Coke is consumed, which is 7. And if you remember your old theory of diminishing marginal utility, you know that when you consume more commodities, your level of satisfaction increases. That means initially 2 was consumed and 5 Coke was consumed. But now 2 is still consumed. You will maintain the same level of satisfaction that is coming from gari, but 7 Coke is now consumed. In that case, you will maintain a higher level of satisfaction coming from Coke. That tells you that this indifference curve, this total satisfaction derived here, must be higher than this one. But this analogy is different from moving from this point, coming down, say, to this point. At this point, if you move from here to here, it is no longer 2 Gary you will consume. Gary must drop maybe to 1 for Coke to increase to 7. There must be a trade-off. Economics is a theory of trade-off. That's economics. So that's why you cannot have your cake and eat it. You cannot be in Sokoto and be in Zamfara. Okay? So in the theory of economics, there must be a trade-off. The movement from here to here shows that not only 2 Gary is being consumed, there must be a reduction in the quantity of Gary consumed for you to consume more Coke. But the movement from here to here shows that the same level of Gary is consumed and more Coke is consumed, just like your PPC, production possibility curve, where you have increase in technology and when you have trade-off in your labor and capital employed. Have I answered your question?
Yes, sir. Yes, sir. Yeah.
All right. The next fourth property is that the indifference curve is convex to the origin. The indifference curve is convex to the origin. Who can help me explain what I mean by the indifference curve is convex to the origin? I should be able to give the person 5 marks in your test.
Oh yeah, yes, I'm sure here, sir. It shows the shape of the indifference curve. So you see it's having like a C shape to the origin. That's the meaning of the convex shape.
Who is speaking? Funsho, right?
Yes, sir.
Okay. Any other person? Please, you can answer what he said if you feel that is the answer. So your Funsho's 5 mark does not stop Olandeji's 5 mark. So if you feel is correct, you can say is correct. If you think is wrong, you can say is wrong and tell me the answer. What do I mean when I say the indifference curve is convex to the origin?
Does not have negativity.
Any does not have negativity. Any other opinion? All right. No, no opinion. Don't worry. You have checked. You have checked the answer. Don't worry. You have checked the answer on the internet. Don't worry. It's okay. Don't talk again. Let me now answer. Now, the people that have said they tried, but it's wrong. The convexity of a curve. What does that mean? The convexity of a curve means that you are willing to give up, please mute your mic, means that you are willing to give up more of what you have just to get less of what you don't have. That is the convexity of a curve. Let me explain why I say you are willing to give up more of what you have just to get less of what you don't have. Let's take, for example, this is point A, and this is point B, all right? Now, at point A, look at the quantity of Q2 that was demanded, that was consumed, and look at the quantity of Q1 that was consumed. At point B, look at the quantity of Q2 that was consumed, and look at the quantity of Q1 that was consumed. Moving from point A to B, what has happened? There's a trade-off. And the trade-off is that I gave up. Look at the magnitude of what I gave up. Look at how big it is. Just because I want to get this small thing. Have you seen it? So this curve is convex to the origin, meaning I am willing to trade off more. Look at the quantum of Q2 that I already have just to get little of what I don't have. This is the lifestyle of a consumer. A consumer is oju kokoro, kokin telorun. The consumer is willing to give up more of what he has just to get small of that thing that he does not have. That is why you see someone will just buy a Toyota Venza, new one. Okay, no, someone will just buy iPhone 13. Abi, which one is the latest now? It's 14, Abi. So someone will just buy iPhone 12 Pro. And how much is iPhone 12 Pro? Say 500,000. And then iPhone 13, 14 Pro will come out. And how much is iPhone 14 Pro? 800,000. You know that the moment you buy that new phone, it has become second-hand. And you bought it 500,000. Next week, Ojukokoro, you are willing to sell that iPhone 12 Pro for say 300K, just because you want to get that new one that is 14,000. So a consumer will always be willing to give up more of what he has just to get less of what he does not have. And that is the economics of side chick that dangerous men are pursuing, which is not good. You see a man that is married, has wife. The wife cooks for him. The wife washes his clothes at times. The wife takes care of the children. The wife provides for the children also. And the wife is doing everything. The wife will now ask the man, give me money. I need money. I don't have money. There's no money. There's no money. But that man will be pursuing one tiny, slim girl outside there. And that man will be giving that girl 100,000, 500,000, because the man wants to get small attention of that girl outside. What is happening? The man is willing to give up more of what he has just because he wants to get that small time outside. That is consumers for you. Okay? So
Perfect example.
that is why the man, the wife at home is asking for 10,000. No, it's 10,000. The wife at home is asking. No, and the man will be telling her, I don't have money. They've not paid us. There's no salary. Where one Bengali outside. Hello, I need, hello. It's 50,000. Hey, 50,000. Hey, okay. I will send it. The man will send 50,000 because he just want to get small temporary time. Small is just 30 minutes or 1 hour at one corner. Why the wife is everything is available morning till night at home. He is willing to give up more of what he has just to get less of what he does not have. But for the producer side, when we get there, that one is concave to the origin. Meaning what? That one is willing to give up small of what he has just to get more of what he does not have. That is why you see a producer mentality. He's asking, how can I invest this 10,000 naira so that I can make 50,000? That is a producer. And that is the mentality you should have. Don't have the mentality of a consumer. So the producer will always be willing to say, how can I give up this small to get more? That is why an entrepreneur will sack, or if an employee resigns and japa, if that employee is doing 5 tasks, the entrepreneur will be aiming to employ a new staff that will be doing 10 tasks. That is a producer. That's why is curve is concave. That's why the production possibility curve is concave to the origin. So the convexity of an indifference curve implies that there is a greater trade-off of what the consumer has just to get less of what he does not have. Have I made myself clear? And I believe you can remember that example.
Clear, sir.
Don't worry, we'll soon be done. I know I'm wasting your time.
The example is perfect, sir.
The women will say the example.
I know women will support. I know women will support.
Excuse me, sir.
They know their way now.
Sir, use sugar daddy as a example.
I can't hear you. Sorry.
I said based on the analogy you gave on the conversion
Okay.
of indifferent cause, is it synonymous with the principle of marginal rate of substitution?
No. Marginal rate of substitution that's the next thing we want to do. Measures the rate at which I'm giving up one to get the other. But when it's convex, I will give up more to get less. But when it is concave, I will give up less to get more. But the MRS measures the rate of substitution. It's just measuring the rate of substitution. That's MRS. We'll do that. That's the next thing we want to do. Mercy King, please, your question. Your hands is raised.
Sir. Yes, sir. No, sir, that means we can equally say that the convexity in indifference curve is only applicable to consumers only, while the convexity,
Concavity.
concavity is applicable just to the producer only, sir.
Of course.
Okay.
That's why there are two different categories.
All right, sir. Thank you, sir.
All right. So let's now look at the rate of commodity substitution, which is what my friend just asked. Now, what is my rate of commodity substitution? The rate of commodity substitution measures, calculates that rate at which I'm giving up one commodity to get the other. All right. And I can easily calculate it. Very simple. Very, 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 very simple. Now, if my utility function, all right, is equals to a function of Q1 and what? Q2. All right. Now, I will take a total derivative of this function. You must have done total derivative in your maths in year 2. I'm sorry, please cast your mind back on that. If I take a total derivative of this function, that means du, all right, the total derivative will be equals to, I will differentiate this function with respect to F1. With respect to Q1. I will differentiate the function with respect to Q1. Okay? If I differentiate the function with respect to Q1, I will call that answer F1. All right, that's F1 dQ1. I pray you will cast your mind back to total derivative. Please, I might not be able to explain that here because you must have done that in your year 2. Then, if I differentiate this function with respect to Q2, that will be F2, which is the function itself. When we do an example, you will see it dQ what 2. But remember that for an utility function, the level of satisfaction does not change, but the rate at which you give up one good or the other changes. But that satisfaction does not change. There are two different things. The rate at which I'm giving up goods and the satisfaction I'm deriving. The rate at which I'm giving up goods changes, but my satisfaction does not change. So if my satisfaction does not change, that means du will be equals to what? 0. And then this one becomes what? 0. So 0 will now be equals to, I will write all of this to be here. Then I will take 1 to one side, the other one to the other side. If I do that, that means minus F2, all right, dQ2 must be equals to what? F1 d what? Q1. I will divide both sides by dQ1, divide both sides by dQ2, such that if I divide both sides by dQ2, all right, so that means anyhow I do it, dQ1, dQ2, later you can check the mass, please. must be equals to F1 over what? F2. This is my marginal rate of what? Substitution, which is just the differentiation of my function with respect to Q1, the differentiation of my function with respect to Q2. When we take an example, you will see that. Okay, now let's now look at utility maximization. How do we maximize utility? In maximizing my utility, there are two conditions: first order condition and second order condition. In my utility function, remember, I started by saying a consumer has an objective and the consumer has resources. The objective is to maximize profits. The resource constraint is his income. So the consumer cannot spend beyond his income. Now, what is the objective of the consumer? The objective of the consumer is to maximize satisfaction utility. And utility is defined by U is a function of Q1, Q2. I've shown you before. But this consumer has resource constraints. That resource constraint is the consumer's income. Let the income be Y what? Y0. This income, it can use it to spend on either goods 1 or goods 2. What is goods 1? Q1. What is goods 2? Q2. How do I know the expenditure on Q1? Of course, very simple. The price of Q1, which is P1, times, the price of, where's my cursor? The price of Q1, which is P1, times the quantity consumed. So if I have 100 naira, okay, and I'm to either buy biro or pencil, how much is one pencil? How much is the price of a biro? 10 naira. How many quantities of biro am I buying? 2. What's my expenditure on biro? 10 times 2. Simple as ABC. And then what about the Q2, which is pencil? I will check the price of pencil, which is P2, times the quantity of pencil bought. Total of it gives me my what? Income. So my expenditure is based on what I spend on Q1 and what I spend on what? Q2. How do I optimize this decision? I can only optimize this decision, all right, by setting up a Lagrangian function. I know you must have done that in your maths. So I have my utility function, okay? Let me show you. So I have my utility function. U is a function of Q1, Q2, all right? And I have my budget Y0, all right, is equals to P1, Q1, which is the price of goods 1 times the quantity plus the price of goods 2 times what? The quantity. Now I want to maximize this utility subject to these constraints. How do I do it? I will set up my Lagrangian function, which is V is equals to F of Q1, Q2, all right, plus the lambda, okay? And the lambda, remember, I will take all of this to this side, which is now Y0, minus P1 Q1 minus what? P2 Q2. Okay. Then what will I do? I will differentiate this function with respect to Q1, with respect to Q2, and with respect to what? Lambda. So if I differentiate with respect to Q1, whatever I have here, let me just call it F1. All right. Then if I differentiate this function with respect to Q1, I will have minus P1 times lambda. That is minus lambda what? P1. I will equate it to what? 0. Then I will differentiate the V with respect to what? Q2. I believe you must have done this before. So refresh your mind. If I differentiate this utility function here, I will have f of what? 2. Don't worry, we'll do an example. You will see what is f of 1, what is f of 2. Minus lambda. If I differentiate this with respect to Q2, I will have minus P2. Minus P2 times lambda, that's minus lambda P what? 2 is equals to what? 0. Then if I differentiate this function with respect to what? With respect to lambda, what will I have? All of lambda, if I differentiate with respect to lambda, lambda will go. I'm left with all of this. So that will now be equals to what? Y0, all right, minus P1 Q1 minus P2 Q2, all right, equals to 0. This is the first order condition, and I will solve. But what's my second order condition? In my second order condition, I must set up an Asian determinant. I must set up an Asian determinant. What's my Asian determinant? Very simple. Differentiate this function again with respect to Q1, with respect to Q2, with respect to lambda. Differentiate this function again too, with respect to Q1, with respect to Q2, with respect to lambda. Differentiate this function again with respect to Q1, with respect to Q2, with respect to lambda. So let's go. If I differentiate this function again with respect to Q1, there must be an element of Q1 here, and that will be F11, meaning my first derivative was F1. I'm differentiating again with respect to Q1 again, that's F11. I differentiate this function with respect to Q2. That will still be what? You remember, this first function is F1. Then with respect to Q2, will now be F12. I differentiate this function with respect to lambda. There's lambda here already. That's minus what? Minus P1. I come to this second function. I differentiate this function with respect to Q1. That will be what? The function already is F2. But I'm differentiating with respect to Q1. That's F21. Then I differentiate this function again with respect to Q2. The function already is F what? F2. But I differentiate it again with respect to Q2. That's F22. Then I differentiate this function with respect to lambda. There is minus lambda here. So that will be minus what? Minus P2. Then this is the third one. I differentiate this function with respect to Q1. If I differentiate with respect to Q1, this is the answer here. I have minus what? P1. I differentiate it with respect to Q2. I have what? Minus what? P2. Then I differentiate it with respect to lambda. There's no lambda here. I will have what? 0. This is what we call an Asian determinant. Now, if I calculate the determinant of this function, it must be greater than 0. That's the second order condition. So the first order condition is to differentiate all of this function, equate it to 0. The second order condition is that this second derivative, the determinant must be what? Greater than 0. And of course, you know how to find the determinant of a 3x3 matrix. You can do that later and tell me the answer. F11, it will cover this and this. it will not cover all of this. You find the determinant F1, 2, you do that, it will cover this and this, and you solve. Okay, let's take an example and we can call it a day. So this is the example. So the example says is already in your module. Given the utility function of a consumer as U equals to Q1, Q2, and the price of Q1 and Q2 respectively as 2 naira and 5 naira, with consumers' total income for the period as 100, find the optimum commodity purchase of this consumer. Okay. So maybe somebody can snap it or screen grab it. So I have Q1, Q2, then I have the prices as 2 naira and 5 naira. Then I have income as 100. Let me set up the Lagrangian. Let me set up the Lagrangian. So if I set up the Lagrangian, that means my U is equals to what? A function of Q1, Q2. And what's my income? My income is 100 naira. What is the price of goods one? Is 2. That's Q1 plus what is the price of goods 2? Is 5 naira. That is what? Q2. Let me confirm that I'm correct. Yes, the prices are 2 and 5, so I'm correct. Okay, so my Lagrangian is set up as V is equals to what? F of what? Q1, Q2, all right, plus lambda, Abby, and then I will now have what? 100 minus what? 2Q1 minus what? 5Q2. Okay.
So it's plus 5.
Oh, no, it's minus, it's minus, it's minus, it's minus. But
It's
note,
minus.
note that the function is not, the function is not implicit. Please take note. This function is not implicit. It's just Q1, Q2. Please. There's a difference between that and this. So the function is not implicit. All right. So I will take dv d what? dq1 will be equals to, if I differentiate this now with respect to q1, what will I have? Q2. Because this is now a function. It's not implicit. That's why I'm not having f1. That f1 now here is q2. So if, for example, here is q1 0.5, for example, assuming we have this example, that means you just differentiate this function with respect to 0. With respect to this, 0.5 will come down, 0.5 minus 1. You should know how to do all of those differentiation. Okay, that's Q2. If I differentiate with respect to Q1, I have minus 2. Minus 2 times lambda. That's what? That's minus what? 2 lambda is equals to what? 0. Then I will do dv d what? dq2. And if I differentiate this with respect to q2, the answer will be what? q1. Then minus, with respect to q2, I have 5. That's minus 5 what? Lambda. That's equals to what? 0. Then I will do dv d what? d lambda, which is just equals to all of this that I have, which is 100 minus 2q1 minus 5Q2 is equals to what? 0. Okay? Remember, I can find the ratio of these two. Since this equals to 0 and this equals to 0, that means Q2 over ratio of Q2 over what? Q1 will also be equals to what? Minus, will also be equals to, no, minus we cross the other side. Will also be equals to 2 over what? Over 5. So that means Q2, if you do this, will be equals to what? 2Q1 over what? Over 5. Cross multiply 5 times Q2, 5Q2 is equals to 2 times Q1, 2Q1. Divide both sides by 5. Q2 will be equals to 2Q1 over 5. I will substitute this Q2 equals to 2Q1 over 5 into the budget constraints. So that what will I now have? I will now have 100 is equals to 2Q1. Okay, 100 equals to 2Q1 plus 5. What is Q2? Q2 is 2Q1 over what? Over 5. 5 will cancel 5. Then 100 is equals to what? 2Q1 plus what? 2Q1. If you had it, then 100 is equals to what? 4Q1. Divide both sides by 4. Q1 will be what? 25. Right?
Yes.
So if Q1 is 25,
Yes.
then 100 should be equals to what?
Okay.
2
Maureen.
times 25. Please, somebody is talking. Please mute. 2 times 25 plus 5Q2. 2 times 25, 50. 100 minus 50, you know, that's what? 50 is equals to what? 5Q2. Then what will be Q2? Q2 will be what? 50 over 5. Q2 will be what? 10. So that means 25 quantities of goods 1 and 10 quantities of goods 2 are needed to maximize what? Satisfaction. Are we together? So you can later do the Asian determinants for this. If you are to do the Asian determinant, you differentiate this with respect to Q1. There's nothing here in this second function. There's no Q1 there. So that will be what? 0. You differentiate it with respect to Q2. There's Q2 here. That will be what? 1. You differentiate with respect to lambda. That will be what? Minus 2. In the second one, you differentiate with respect to Q1. There's Q1 there. That is 1. You differentiate with respect to Q2. There's no Q2. That is what? 0. You differentiate with respect to lambda. There's lambda there. That is minus what? 5. The last one, you differentiate with respect to Q1. There's Q1 there. Was it? Minus 2. You differentiate with respect to Q2. Was it there? Minus 5. You differentiate with respect to lambda. There's no lambda. What will it be? 0. Find the determinant of this. It must be greater than 0. If you find the determinant, you know the first one is 0. It covers this and this. 0 times anything will be 0. The next one will be what? Minus 1. Later you check. Minus 1 will cover this and this, but not 1 minus 5. Remember your matrix. Minus 2 and what? 0. You close this. Minus 2, which is the last one that is up here. It will cover this and this, but it will not affect 1, 0, minus 2, minus 5. If you do the determinant, that will be minus 1 into 1 times 0, 0. Minus this, that's minus 10. Okay? Then minus 2. you do the determinant. 1 times minus 5, minus 0. You see, minus 1 times minus 10, that is 10. Minus 2 times minus 5, that is plus what? 10. That means the determinant is what? 20. And 20 is greater than what? 0. So the first order condition is satisfied, and second order condition is also satisfied. Any question?
Please, how do we get the -5 at that initial part? Please, sir.
Differentiate this second function with respect to Q1. It will be 1.
No, not here, sir.
Where?
At the initial part, when we started, before the Lagrangian function started, when we are trying to improve the Lagrangian function.
That's the price of goods 2 now. Price of goods 1 is 2. Price of goods 2 is 5. 2.
But the time we got initially was a plus.
Yes. When you do just maybe
suddenly change it to a minus.
Somebody should explain better. Maybe later you can do a tutorial on it. When you want to form your Lagrangian, everything here will cross to this side. Everything here will cross to this side. So it will now be 100 minus 2Q1 minus 5Q2.
Okay, thank you, sir.
Any other question? So let me stop the recording.